Okay, guys, so today we're going to find some special products. Okay, so I want to just dive right into our first example. Um, so first, let's observe a pattern that occurs when a binomial is squared. We're going to square some binomials or multiplied by itself. Let's find the square of each binomial in A through D and use the product to answer the questions that follow. Okay, so we're going to square x plus 1. So that means we're going to multiply x plus 1 times x plus 1. And you could do FOIL. You could do box method. So let's just multiply. Let's see, I like FOIL. So first, outside is x, inside is x. Add those up, that's 2x. And then last is 1. So that's usually how I do it mentally. I do the outside and inside in my head, get the sum, write it in. Okay, so we got that. Okay, so for the next one, we've got x squared minus 6. Okay, so let's see. First would give us x squared. Outside would give us negative 6x. Inside would give us negative 6x. If I add those two negative 6x's together, that's negative 12x. And then negative 6 times negative 6 is plus 36. Okay? All right, now, guys, come on. X plus 5 times x plus 5. X squared, 5x. 5x gives us 10x. And then 5 times 5 is 25. Well, last one. We're going to do 2x minus 3 times 2x minus 3. And again, for x squared, we can write that one down. Then we do negative 6x, right? If I do the outside, it's negative 6x. If I do the inside, it's negative 6x. Negative 12x, yeah. Hopefully you start seeing a pattern that we're always doing there. And then negative 3 times negative 3 is plus 9. And this is the harder of the two patterns, by the way. Okay. So there we go. So it says compare the products above to their original squared binomial and describe any patterns you notice related to the following. The first term. Okay? So the first term was x. And what do you notice there? Yeah. It's always the original one squared, right? X squared, x squared, x squared. Here we had 2x. You square 2x, it's 4x squared. So it was always the first term of the binomial squared. Okay. Look at the last term, the 1, the minus 6, plus 5, minus 3. The last number squared. 1 squared is 1. Negative 6 squared is positive 36. Positive 5 squared is 25. Negative 3 squared is positive 9. So it's always the second term, I guess you could say. It's the second term in the binomial. Always the second term of the binomial squared. Those are the relatively obvious ones to see. Okay? You can see that you square the first term, that's the beginning of your answer. You square the second term of the binomial, that's the last part of the binomial. Now that middle part, that middle term. It actually came from a combination of both of these. Yes? Multiply the inside and double it. Let's test it out. X times 1 is 1, right? Oh, it is 1x. But if you double 1x, you get 2x. X times negative 6 is negative 6x. But if you double it, it's x times 5 is 5x. But if you double it, basically that's what it is. 2x times negative 3 is negative 6x. Negative 6x times 2, negative 12x. So basically, first term times second term times 2. Okay? Huh, it works. As long as this is your notes, guys, you could use whatever shorthand makes sense to you. Okay? All right. So what we're going to do next is kind of develop that unique pattern. So there's a unique pattern that we're going to get. So the way we're going to get this is by multiplying or squaring a plus b and then a minus b, okay? And that will give us like the general pattern. Okay, so let's put a and b here and a and b here. We'll multiply this using the box method, right? So we'll multiply a times a, and then a times b, that's ab. And then we'll do multiply across by b. B times a is also ab. I'll put those in alphabetical order. And b times b is b squared. So it's a squared plus, since they're positive, remember we combine. Well, what do I'm adding AB with AB to AB. And then B squared. So this is the general pattern. You replace A with whatever the first term is. You replace B with whatever the second term is. And then you follow that pattern. It's just what we broke down and discussed right there. You square the first term. For the middle part, you multiply them together, the first and the second term, and multiply it by 2. And then you square the last term. There you go. So if we have a minus, it'll be a little different. So I'm going to put, I got to have negative b, right? So let's multiply these. I'm going to have a squared minus ab, and then negative b times a is negative ab, and then negative b times negative b is positive b squared, so just write b squared. Once again, the only part we really have to worry about is combining those correctly. It's a squared, again, just squaring the first term, minus 2ab. Only difference here is it was plus there, minus there, plus b squared. Okay. And there we have the general pattern. Okay. Uh, um, Trinomials written in this form above are called, um, well, they're called squared binomials as far as I know. Hmm. They're called really binomial square trinomials. So what I'd like us to do is let's kind of use that pattern. Now, if you're still not comfortable with it, you could use a box method, you could use FOIL, but let's just try to see if we can figure it out using this pattern. So we got x plus 9 squared. So our a value, this is our a value, and this is our b value. Okay, so it's x plus 9 squared. A is x, b is 9. So it would be a squared, which would be, in this case, then you take both of them and multiply them together and multiply it by 2. 18. X times 9 is 9x plus 2 is 18. And then you square the 9. There it is. Hmm? Yeah, because it's 9 squared. Nope. 9 times 9 is 81, right? Okay. All right, guys, come on. Let's try this one. Your a is x, your b is negative 7. So what's our first term? X squared. Again, multiply these together and then multiply it by 2. Negative 14 x. And then you take negative 7 and you square it. Plus 49. Okay. M minus n. Okay. Your first term is a, your second term is negative, yeah, negative m squared. Multiply them together. What's m times n? M times negative n. Negative mn, but then you multiply that times 2. And then you take negative n and square that. Mm-hmm. All right, last one. Challenge. Try it. Your a is 4x. Your b is plus 2. Okay, so hopefully you got this. Any questions on that? Remember, for that middle term, it's 4x times 2. That's 8x. You multiply that times 2. That's how I got the 16x. Okay. Write the expression for the area of a square whose sides are 3x minus 2. Okay, so that for the area of a square, this is the formula. The area is any one side squared. Yes. All right, any one side squared. So basically what they're asking us to do is take 3x minus 10, square it. So the area would be this squared. So that would be what? 9x squared. minus 60 plus 100. 10 times 10. Okay. Any questions? So that's the square of a binomial. Okay. Let's, Yes. There's another pattern I'd like to show you, and it's over here. It's called the difference of two squares. This one? I think you already anticipated. Let's go ahead and quickly multiply these using FOIL. We get x squared, negative 3x, and then positive 3x. They cancel. So then I multiply 3 times negative 3. Let's try that on this one. First would give us x squared. The outside would give us 5x. The inside would give us negative 5x. They cancel. Then I multiply negative 5 times positive 5. Okay, let's try this one. There seems to be a pattern here. 9x squared. Then we would get 6x and negative 6x. They cancel. So negative 2 times 2 is negative 4. All right. The last one. Then we get negative 24x and positive 24x. They cancel. You have too many friends. All right. I think we see what the pattern is here, right? The middle term just disintegrates. All right. So it says compare the products above being multiplied. Describe what happens when multiplying a sum of difference of two squares. A sum and a difference of the same one. What happened? So what happened? First term squares. No x. Middle term disappears. Last term. Mm-hmm. Yeah, it's basically, since you're multiplying a negative and a positive, you always get minus the minus last term squared. I can't fit it. Okay. So basically, the product of a plus b times a minus b results in the square of a minus the square of b. In other words, it equals a squared minus b squared. So this form a squared minus b squared is known as the difference of two squares. The difference of two squares. It's once you recognize it, you got to have the sum and the difference of the same binomial. The sum and the difference of the same binomial. So what are we going to get here, guys? Yeah, we have it here. So this would be m squared minus n squared. We'd have it here. So this would be okay, pretty straightforward. Okay. Um, so it says Maya needs to find the product of 4x plus 8 and 4x plus 8. Jude says that she should use the first term 4x, then subtract the square of 8. So basically, he wants to use the difference of two squares pattern. Is Jude correct? Why or why not? Yeah, the second term does not cancel. Yeah. Yeah, if we had 4x plus 8 times 4x minus 8, yes, obviously. So here the middle term doesn't cancel. All right, so give an example of two binomials whose product would result in a difference of two squares. So basically, make up your own problem that would follow this pattern. Make up your own and find the answer. So, should look something like this. Whatever you like. Alrighty. So for the last thing, it says, let's apply what we learned, guys. So use the special products patterns that we've been looking at and match up the product on the left with the answer on the right. So let's match up the letters. So first we have x minus 8 squared. Which of these would give us, which of these is the answer to that? Which one? So it would be x squared. Well, remember, we're going to have a middle term. I heard someone give me a letter. G. Yeah. Yes. All right. How about the next one? That one is the difference of two squares. Which one? That is E. Okay. Difference of two squares again. H. Yes, H. Okay. How about the next one? That one's a squared binomial. Yes, A. Oh, you guys are quick. Last one. Squared binomial again. Yes. All right, and we're done. Okay. So IXL, one IXL for this.